we're discussing linear relationships, basically lines. This chapter, we're doing something called quadratics. And so we better establish the difference between the two before we start. So, take a moment to put your phones away. Take your headphones out. Take out a pencil.
Did you mark the test?
No. And take a look at this. Oh, illness. Okay, the graph of a linear relationship is a, well, this is not tough. Shh. Shh. Headphones out. Not a sneaky one in one ear. Headphones out. Okay, this shouldn't blow your mind, what's coming up here. Last chapter, we looked at linear relationships, and their graphs were lines. And we did a whole chapter on it. It actually wasn't simple and easy. You'd think a straight line would be simple and easy, but it wasn't always simple and easy. But this chapter, the graph of a quadratic relationship is, and if this word is scaring you, that's okay. I'm going to talk about that today. But today we're talking, that's what this chapter is all about, is quadratics. And the graph of a quadratic relationship is called a parabola. And we found out in Friday's lesson, this was this sort of curve that went like this. And we talked about home runs and how every baseball that gets hit in the air follows a quadratic. It curves through the air. I don't mean like a curveball. I mean it goes up, and then it comes back down again. Look, I stopped there because the one in the video that Jose Bautista hit stopped when it hit the second deck. But we'll do parabolas all the way through. We'll do some applications as well. So I hope this next question's easy after saying that. Linear, quadratic, or neither? Ooh, neither. A little scary there. Could it be neither? And here we're just looking at them and saying, is it a line or is it a parabola? What's this first one? It's a line. This is linear. I laughed. I didn't mean to laugh. I shouldn't have laughed. But you might find this part of the lesson incredibly easy. You just look and go, oh, I can tell we're doing a linear versus a quadratic. If I look, it's a straight line, that's linear. If I get a parabola, and look, this is a pretty skinny parabola, but it's still a graph that goes up, curves up, and then curves back down. That's called a quadratic. So from the graph, pretty straightforward so far. From the equations, like usual, the equations will have a little more to them. Well, how about this third one? Is it linear or is it quadratic? Is it a straight line? It's quadratic. Okay, so yeah, these aren't meant to be extremely hard, this part of it. And the last one, is it a straight line or is it a quadratic? Straight line. Straight line, okay. That should be enthusing, where you go, hey, this deciding between linear and quadratic thing's not too bad. The next ones will seem harder, but then I'll tell you one thing, and hopefully you'll be like, oh, okay, so that's not so bad. Any questions thus far? Thus far. Look at me with my big fancy words. All right, if we are given an equation, how can you tell if your relationship is linear or quadratic? Okay, pressure's on me to keep this brief. Linear. Joseph has some input. What do you say, Joseph? Were you going to answer?
Yeah. You tell by the slope is?
Oh yeah, if you see the slope. So let me just try and put that in here. Linear. Only y equals mx plus b or rearranged. I think that kind of brings his answer into it. If you could find the slope of it, then it would be linear. But I'm going to give an even easier guide to this. No exponents. On the variables. That might be an easier definition to work with as we start. And I'm not going to get all technical and say, well, even x has an exponent. It has exponent 1. No, we'll just leave that kind of thinking on the shelf for just a minute. But here's quadratic. And not something crazy coming here. The x has an exponent 2 somewhere. There, that's all. There are other explanations of that, but that's the simplest one I can think of. Say, oh, if you see an exponent 2 somewhere on the x, and we're not going to go exponent 3, exponent 4, exponent 5. We're not going to do that. This whole chapter is just, if you see exponent 2 somewhere, you're talking about a quadratic. Let's look on the boards here. This was all from the math help room today. Oh, look over here. Do you see this one up here? It says 2x squared minus 5x minus 3. That one's a quadratic because it's got an exponent 2 on the x somewhere. There's one over here. They were doing a crazy word problem in 11 university math. This one over here, negative 30x squared plus 300x plus 250. That one is also a quadratic because it's got an exponent 2 somewhere. If you see an exponent 2 somewhere, you're talking about a quadratic. If you only have regular x's, like y equals mx plus b, then you're linear. That's all. That's all. No extra details here. That's all we need so far. Are quadratics going to get difficult? Well, yeah. As the chapter goes along, they will. But here, not too bad. Not too bad. Jackson, do you have a sheet? Yeah. Do you need more time there? Okay, is that still on your page, though? You'll be able to look at it as we try these ones. Our job, there's 8 of them. No, there's 10 of them.
Are we answering these by ourselves?
No, we'll do them together. But let's do it a weird way. Can you look through the 10? Is there one of them there you can look at and go, I know which one that is?
The first one,
The very first one he says, yes, I know what that is. What is it?
linear.
Linear, yes. That's what we were doing last chapter. That's what Joseph was saying. I could see the slope is 2, the y-intercept is 7. There's y equals mx plus b. That's a linear one. What else do you see that you look right at and you go, I know what that one is?
The second one?
The second one, what's that?
Quadratic.
How do you know it's a quadratic?
Because it has an exponent of 2.
It has an exponent of 2 on it. Okay? There are some tricky ones on the page here, by the way. But those aren't them. Those ones are easy to pick off. But there's more easy ones to pick off. I think there's at least 2 more that are not too bad to pick off. The fourth one, this one here, what do you like? Quadratic, absolutely. Because it's got an exponent 2. If you see exponent 2 on x, you're talking about quadratic. Okay, I'm going to jump to a tricky one. The last one. 4x cubed minus 5x squared plus 8x minus 1. The way I explained it, you might believe it's a quadratic. The way I wrote it, not the way I explained it. I did mention it. This one goes up to exponent 3. No, we're not doing that. We are not doing that. This is neither. Making me want to fix my note. I'm going to add 2 words to my note. I'm going back. It said x has an exponent 2 somewhere. At most. Yeah? Nothing above exponent 2. Can we do that in other courses? Yeah, we can look at higher exponents. But in this course, exponent 2 is the most. All right, there's now 1, 2, 3. That might still be okay. We're getting a little harder here, but there's 1, 2, 3 that might be okay. And then there's 2 really tough ones. This one's linear. If I tried to fool you, it was just with decimals. And we didn't do a whole lot of decimal crazy ones last chapter. But just decimals, that doesn't mean that it's not slope and y-intercept. It is. What about this one?
Linear.
That's linear as well. It's missing a b, but that just means that the y-intercept's 0, so that's no problem. What? Oh, yeah, I think there is one more easy one. The sixth one. 1, 2, 3, 4, 5. Sixth one? This one? We got to talk about this one. So I'm going to put a star beside that one. We have to discuss that one because that's a tough one. There's a tough one, and there's a tough one. There's 3 tough ones on there, and those 3 tough ones will start to give you a feel for the challenges of this chapter. But this one isn't bad, actually. Even though it's crazy fractions, it's not bad. It's linear. It's just y equals mx plus b. I know the numbers are funny, but it's just x's and numbers. Now, I know why he said this one was linear, because it's just x's and numbers. But to really be able to see it, I've got to multiply it out and see what it is without the brackets. And when I multiply that out, what's x times x? x2 or x squared. That might be enough right there to already answer, but I'll finish multiplying it out. So this is why distribution is going to become important to us. So that's a quadratic. And I encourage you to multiply them out to be able to see if they're linear or quadratic. It is possible to see. I'm going to multiply this one. This next one down here, x plus 7, x minus 8. I'm going to multiply it out in a second. But can anyone look at it and know what's going to happen? What's going to happen to this thing? Right, so if I go x times x, I'm going to get x squared. So if I've got two brackets and they both have x in them, that's going to come out to x squared, and I'm going to get a quadratic. But I'll do it. See, if I multiply this out, I get x times x, which is x squared, x times negative 8, which is negative 8x, 7 times x, which is 7x, and then negative 56. Now, if you don't remember that at all, please do not panic. That is not the main part of this lesson. Today I'm just like, hey, we might have to do a little algebra here before we can tell for sure. If it's just all written out and all the terms are separate and there's no brackets, there's nothing to worry about. But I got to teach you more on this. Okay? So if you see a linear bracket and another linear bracket, that's a quadratic. More on that coming. So again, the ones with stars, I don't want you to panic about. If you understood all the ones that don't have stars, we're in good shape. If the ones with stars, you're like, Mr. Todd, you're going to have to do better than that before this chapter's over. I know. I just mentioned it now that I'm like, those ones could fool you. You can't just look and see, is there x? You look and go, is there x after I distribute it? So we will do more distribution. Any questions there? All right. Now I just got to tell you about table of values. And then maybe we'll do a bunch of the homework together. Maybe that's what we'll do. We'll knock down a bunch of the homework together. If we are given a table of values, how can we tell if it's linear or quadratic? Linear. All right, I got two sentences to say. I got to talk about linear, then I'm going to go do a couple tables, then I'm going to come back to quadratic. Because this is actually a little bit tricky to cover all this. So first, this is something hopefully you saw in grade 9 actually. If you didn't see it in grade 9, I'm teaching it like you completely forgot it, or maybe the teacher didn't get to it, or whatever. For a table of values to be linear, the table will go up by equal values. It'll go up by the same thing every single time. Sometimes called the first differences are equal. When I say first differences, does that ring a bell from grade 9? It's okay if it doesn't. I'll underline it like, okay, there's a new phrase we need, first differences. If you're like, why is it called first differences? Well, as soon as I do a couple tables, I'm going to show you why. Okay? And then I got to come back here. So hopefully there's still some space to write underneath there because I got to come back to these in just a minute. All right. I'll come back to this. So if you don't have a copy down, let's go back. Let's go to the tables and talk about how we use it. Does this first table of values go up by the same amount every single time? Yeah, what's it going up by? 2. And the reason it's called first differences is to figure out that first difference, you could go 11 minus 9 equals 2. Most people wouldn't. They just look at it and go, oh, I see it's going up by 2. But when the numbers get complicated, it might get a little difficult to do that. And see, this one is 13 minus 11, which is 2. And this one's 15 minus 13, which is 2. It's okay if right now you think I'm crazy to write all this out. Because some of you already could just see that it was going up by 2s. But if it's going up by 6.7s or 84s, it might be a little difficult, so my method will become better there. So I'm just showing you the method if the numbers are complicated. And because those numbers were all the same, this one's linear. Does this one go up by the same thing every single? No, it doesn't. And let me show you what it goes up by. It goes down 2, then it goes down 6. This is hard. It goes down 10, and then it goes down 14. Can you hear the train going by and seeing my screen moving? Is that a little freaky? A train across the street is shaking my overhead projector. Yee! Do we agree it's not linear then?
Yeah.
It might still be quadratic. And I got to talk about that, and I will in a second. For now, I'm just on a linear hunt. I'm just going looking for linears. I'm going to act like that's all we're looking for, and then I'll come back and look for quadratic. So far, I don't know what that is, whether it's linear or quadratic, because there's another choice. It doesn't have to be linear or quadratic. All right, let's go down to the, how many tables is there? 6. Let's go down to the next one. Does this one go up by the same amount? No. That's giving me vertigo. Do you see that shaking still? Not linear. I don't know how to tell if it's quadratic yet in this lesson, but not linear. How about this one? Not linear. Don't get carried away and decide it's quadratic yet. It could be neither. No? I'm not down to the last 2 tables yet. I'm just on a linear hunt. If you're getting annoyed because I'm not chasing quadratics, it's because I haven't explained it yet. All I've said is linear means they're going up by the same amount. Are either the last 2 linear? Maybe, eh? Oh, maybe one of them is. Okay, so there's one more linear out there. This one here. 78 minus 81, it's going down 3. That's why it's called first difference. I'm subtracting to see how much it went up or down. This one, down 3. This one, down 3. Oh, I'm having trouble with my 5s today. Did it go down by the same amount every time? So that's linear. That would be a straight line. This one. Okay, not much to say. Lesson almost over. Well, we'll do some of the homework together. But the lesson part is over. We found 2 linears, and then we found 4 that might be quadratic, but I haven't explained how we would know. Every little bit of brain power, save it up for the next couple of seconds. Back to here. To be quadratic, the second differences are equal. And I need to just get my screen ready because I can see I don't have enough space on my screen for the next ones. I'll go back to this. If you don't have a copy, don't worry. I just want to fix up my other screens. Don't worry, I'm going back to it. I just got to get myself some space here. Ooh, hey. Oh, I was going to go back, wasn't I? Do you need more time for this sentence here? The second differences are equal. And it's okay as you're writing that, like, I don't even know what a second difference is. That's okay. Because I'm going to do it. I'm going to show you how to do second difference. What's that? What's happening? Mr. Todd, your shirt's too bright. I can't even look at you.
It's not that bad. It's not that bad. You look like a little bumblebee.
I look like a little bumblebee. Aren't bumblebees fat? You call me fat?
No. Wow.
Now you look like a wasp.
I look like a wasp. That's good. All right. We're not worried about number one. That was already linear. Take a look here at the first differences. -2, -6, -10, -14. Do you see what's happening with the first differences?
Yeah, right now. Wait. Yeah, it is, actually.
Yeah.
Going up by 4 each time.
Going up by 4 each time. So this actually it's down by 4. That doesn't matter. Down by 4, down by 4, down by 4. The second differences are equal. So this is quadratic. Yeah? So you do the differences, then you see if there's a pattern to the differences. And if the differences go up by the same amount, it is quadratic. Incidentally, this works for higher degrees too. If we want to know whether it was degree exponent 3, you do the next differences. But we don't do that in this course. Yeah? We just do first differences, and then if that doesn't work, we try second differences. What's that? It does it. This one does it the first time. Right here, it goes up by 2s. This one, it doesn't do it until the second differences. Good. Perfect question. Yeah. That's why I did the linear first. Yeah? Let's check this one. There's the first differences. They're not all equal. But are they going up by the same amount every time? How much to go from 3 to 5?
2.
To 5 to 7?
2.
7 to 9?
2.
That's a quadratic. So you get 2 shots at it. What about this one?
I know. So it's doubling each time. Or no, it's going up by 2 and it goes up by 3.
Yeah, so this is neither. This is something else. We will talk about it in grade 11, what the heck is going on here maybe. But for us, we just go, oh, not quadratic. I'm out. Yeah. Yeah? Is it okay? Because it didn't go up. See this? 1, 2, 3. They're not all equal. It's got to be the same number every single time to be a quadratic. 2 more tables to go, yes? Oh, no, one of them was linear, wasn't it? Yeah. We already found a linear one. Now this one. Is it going up by the same amount? How much to go from 0.2 to 0.6? 0.4. Now, all those times I was subtracting, you're like, why is he subtracting? I'm only subtracting when it's hard. Yeah? So then I can go 0.6 minus 0.2, that one's 0.4. So when it gets hard, use your calculator to do the subtraction. If they're just nice, easy numbers, you don't have to do all this crazy stuff. How about 1 minus 0.6? 1.4 minus 1. It's a quadratic. Is that easy? Ooh, I don't know that it's easy. But there's a set of steps. Shh. All right, we're going to do the homework together. You're not going to end up with any homework out of this. We're going to do each question together. And those of you watching this video, good luck. There's going to be long pauses here. Ready? Lesson over. The lesson's over. But we're going to do homework together. Is that good? More time here? Yeah? 38 minutes. How many homework questions is there? Maybe we won't get all the way through. How many is there? 1, 2, 3, 4, 5, 6. It'll be close. It'll be close. More time? Now, if we take too long, you can jump ahead. More time? No.
I wasn't done smelling it.
Shh. Back with me, please. Back with me. Side conversation, stop. Not when you finish. Shh. Not when you finish. Phones back away. Shh. Each month, a cell phone company charges a flat fee of $20 plus 25 cents per minute. I know you guys have no clue about this because cell phone companies don't charge like this anymore. But maybe you could think of it as 20 minutes plus 25 cents per gigabyte. Yeah? For data, because some companies still charge like that. Complete the following table. Okay, if I use 0 minutes, how much does the plan cost me? $0. No, still 20. Yeah? Now, someone who's paying attention, what do I do to figure out how much I'm going to get charged for 5 minutes? Not just 0.25.
20, I got it.
It's 25 cents, but for each minute.
20, 21, 25?
21.25. He's right. What's he talking about?
That's $21.25.
Yeah, but how'd you do it?
I just timed 0.25 by 5, and I added that on 20.
Right. He went 25 cents times 5, then add the 20. And what did you get? 21.25. See, this table, it's not trying to trick you, but who's going to go up by 1 minute? Yeah, you're going to go up by 5 every time to say, well, how much for 5 minutes more? So tell me what's right here for 10 minutes.
So it's 20 plus 0.25 times 10.
So what 20 plus 0.25 times 10? If you put that in your calculator, shh. Gentlemen, once I say shh, you don't go, oh, I get to finish what I'm saying. Then I'll stop. No, just stop then. Jeez. How about for 15? I hope I've set it up where it's like, I got it now. How do I do 15?
Do 20 plus 0.25.
23.75. Somebody says, I don't need your little formula to figure this out. I know how to count by $1.25s. Thank you very much. Yeah, that's fine. I like that. As long as you get the right answers. There's other ways to do this. 20 plus 0.25 times 20, you'll get $25. 20 plus 0.25 times 25, you'll get 26.25. You can type in your calculator and see. And this one, 20 plus 0.25 times 30, 27.50. All that to ask the question, is it linear? Does it go up by the same amount every time? Yes. How much does it go up by each time, Jackson?
125.
125. And maybe this particular question, at some point, it becomes obvious and you don't even finish the table out in a sense. You just start copying them down. You realize this is going up by $1.25 every 5 minutes. Every 5 minutes is another $1.25. And at that point, you already decided it's linear. And I'm okay with all of that. I just showed all the steps so you get the idea of how to build the table to answer the question. Do you always need a table? No. You might get good enough at them you can just tell what's going to happen.
Do we always gotta put the stuff in there?
What's that?
Do we always gotta put like the
No, if you get the pattern down, if you're like, I know what's going on here. When I'm teaching, I got to show all the steps, right? And so this is how you do it. But it could be along the way. Maybe by the time he explained it, you might have been like, oh, $1.25. It goes up by $1.25 every time. It's linear, you know? So is this an easy one? I don't know. Somewhere along the way, this might have become an easy question. All right. After that, I tried to make up as silly a situations as I could come up with. I just started playing around, but things that you might find a little bit fun, I guess. Do you need more time here? Here, check this out. Here's the game. Have you ever done this with pop cans? Tried to make a tower of pop cans?
Yeah.
All right. Pop cans are arranged in a pattern called triangular numbers. It actually has a name. Shh. Shh. The top row has 1 cup. The second row has 3 cups, and so on. Our job, find how many cans total will it take. If I do 1 row, how many cans do I need? It's got a picture. 1 can. If I want to do 2 rows, how many cans am I going to need? 3. If I want to do 3 rows, how many cans am I going to need? 6. See, the pictures help you there. Take a minute and see if you can figure out what the next 3 are, and then decide for yourself whether it's linear or not. See if you can figure out what the next 3 rows would be. You can draw on your picture if you want and draw some cans on there.
I think I got it.
Yeah, what do you get?
9, 12, 15. No?
Try drawing what you need under this picture and see how many cans you're going to need for another row. Take a minute and try it. Draw the cans you need for 4 rows. Phones away, please. Austin. Not when you finish. Not when you get around to it. Yes, yes. Then try the next one. Then figure out how many for 5 rows. Then for 6 rows. And that should be enough to go, oh.
Wait, was that? I think I did it right. Yeah, I did. I did it right. No. I got it. What did you get for number 4? 10. I got 11.
Think about it again.
Oh, you're right.
Here's my terrible picture of the next one. How many total is there?
10?
10. Anyone have a way to explain this without me having to draw the next picture?
Every time the number that is
Right, so now I'm going to need 5 more. I couldn't build it from underneath, but if I could, now I'd need 5 cans along there. Shh. So that's 15. Gentlemen, how many cans do I need to get the next row after that? Another 6, so I'm up to 21. Also explaining the first differences. First differences are I'm going to need 2 more cans here, then 3 more cans, then 4 more cans, then 5, then 6. And the question is it linear? Did those go up by the same amount every time? No. So it's not linear. But is it quadratic? Do these go up by the same amount every time? And the answer is yes, and that's a quadratic. If I graph this, I'd get a parabola, or half a parabola at least. There, that's the whole game and the homework. We got to do that 6 times. Would you like to do another one together? What's the third one? I tried to come up with things that were semi-interesting. Oh, total number of high fives. We can do this together if you want. We'll do it together. We'll actually do the high fives from volunteers. Are you ready? At the start of a basketball game, each player is introduced. As each player comes out, the player high fives all the other players that have been introduced. Complete the following table. Use first endeavor. Oh, we'll do that first. We need a table first. Who's going to be the first player on our basketball team to come up here? You come up and stand here. He's the first player out. Actually, stand there so people can go past you. Right there. Okay. He just ran out on the court. How many high fives have been done so far? 0. Now, somebody's got to go up and high. Who's going to be the second player on the team? You going to go up? Just a high five. You go and high five him, and we'll count how many total high fives have been done. 1 high five or high elbow. There we go. How many total high fives so far? One. No, you got to stay up there. You got to stay up there. We got 1 total high five. I'm keeping track over here. 1 total high five. Who's going up as the next player?
Austin.
He's like, no, I'm not coming.
Get up here.
What's happening here? Hold on. I have a game for you today. I know, but there's a game coming up that you can like. I'm the next player on the team. Ready? I'm the next player. Watch. 1, 2. How many total is that now? No.
2.
You guys did 1 earlier.
Oh, yeah,
3 now total. The 1 you guys did, and the 2 I just came out and did. We need a helper. Daniel, will you come?
Yeah, Daniel.
We've done 3 total now. Oh, Daniel. You can go either way. 1, 2, 3 more. What's this? 6 we're up to. Stay, Daniel. Maybe we need one more round and we'll be home free here. Scout, will you come? Will you join our basketball team? You just have to high five everybody. You can do elbows. Do you want to do elbows? Oh, she don't care. Scout's coming around. What's our total? Hey, hold on. Before you start, what's our total right now? 6. Come by and high five everybody. Count them out loud. 7, 8, 9, 10. Oh, come on. We'll do the 1 more. We only got 1 more when we finish it up. Scout, stay. Scout, stay. We need you to stay. We need 1 more person.
That's it. 16. Alex.
Catherine, will you help us out, Catherine? Doesn't want to.
Get Liam. Liam.
Liam's coming. Liam's coming. Oh, hang on. What's our total?
10.
10. How many are we adding?
1, 2, 3, 4, 5.
How many total? 15. All right, have a seat. Boy, that's the difference between grade 10 and grade 9 right there. Grade 9, there were people crying because they didn't get to do it. They didn't get to be in the high five train. Are you done? Okay, first differences. How much did the first one go up by? 1. Then how much did we go up by? 2. Then how much? Then how much?
4.
Then how much?
5.
Is it linear?
No.
No, those are not all equal. It's not linear. Is it quadratic? Goes up by 1, goes up by 1, goes up by 1, goes up by 1. Yes, it's quadratic.
short point guard. Neither that shooting guard.
Catherine, are you copying this down? You left us hanging up there on the high fives. The least you could do is copy it down.
I was good center.
My feelings were hurt. Adam had to wipe away a tear.
Yeah, that's so sad. Sorry.
It's terrible. Scout came.
I'm not in the mood, okay?
All right. Do you need more time here? Catherine does because she wasn't copying it down. What's that? Yeah.
It's okay, my parents don't care enough.
Oh, that. I care enough, Catherine. I don't believe that's true, but even if it is true, I care enough. I care enough to harass you to copy the note down.
She goes by Katie.
I don't know. This might be the last one we do together. I'm getting tired. Shh. Let me read this. Just shh. Oh, be quiet for a second. I almost said shut up on the video there. A tanker truck contains crude oil. The mass of the empty truck is 14,000 kilograms. The mass of one barrel of oil is 180 kilograms. Number of barrels, 0. How much will the truck weigh if it has no barrels in it? How much does the truck weigh? 14,000. What if there was one barrel in there? What do I got to do?
You gotta add that.
Add that on there. So I get 14,180. What if there's 2 barrels?
14.
14. Yeah, add another 180. That might be far enough. You might be like, it's add 180 every time. That's exactly what it is. This has got to be linear. But I'll put them in there. 540, 720, 900. See? We literally build the table by going up by 180s. It's linear. So the linear questions are not meant to be hard. Now we've seen some quadratic ones where you got to go, once you have that, you got to go one more layer.
Really hard, but just time consuming.
Yes. Not particularly difficult, just a little bit time consuming here. Yeah. What was that? Was that number 4? We got one more in us? Oh, no, we don't. 5's a game. That's a great place to stop. 5's a game you can play with your friends. It's called Frogs. You could try it out and play the game. Play Frogs. And then number 6 is about pizza. How can you not get motivated about pizza? So you got 2 questions for homework. Frogs, which you can play with a friend, and pizza.